Alright, hi everyone. Today we're going to talk about the OSI model, specifically the two layers we didn't cover in class, the session and presentation layers. So I want to start out with giving you a brief history of the OSI model. It originated in 1977 by Mike Campia. He wanted to create something to aid in the communication structure for databases and distributed database application. The result was a 7-layer architecture called Distributed System Architecture, DSA. That same year, the British Standards Institute inquired about a standard to define infrastructure computing. What they found was that they adopted the DSA, and it was accepted as a standard with minor refinement in June 1979. Now I just want to kind of give you a brief analogy so you can better understand what we're about to talk about. So there are two kings and they want to communicate with each other. These kings are the application layer. The king on the one side has a legal matter he wants to discuss, so he talks to his lawyer, who translates his message from just common speak into legal jargon. The lawyer is the presentation layer. The lawyer then passes this message to the secretary, and the secretary communicates with the other secretary saying, hey, there's a message coming, and this is the session layer. Then the secretary passes this to the postal manager, who organizes the transportation of the message, so this is the transport layer. He chooses some sort of shipping services dispatcher, which is the network layer, so this could be a FedEx or UPS. And then the network layer, the dispatcher, works in conjunction with a driver, or in this case a sailor, to get the message from one side to the other. So this is the link layer. And finally, that road or sea that they travel on is the physical layer. And then when it reaches the other side, it just goes backwards through the process.
I looked into the session layer, which is actually the 5th layer of the OSI model. It is located above the transport layer as well as below the presentation layer. Its main purpose is to track connections to remote servers. The session layer is where sessions are normally set up, managed, as well as torn down. There are 4 key utilities to this layer: the dialogue management, synchronization, activity management, as well as exception handling. Dialogue management is where it decides which application can talk at which time, and also when using ISO protocols, it uses a thing called a token, which only allows you to transmit your data once your token is processed. Synchronization moves entities into its own state, so it deals with the errors in the upper layer, such as the session layer, the presentation layer, application layer, and it also uses sequence numbers. So if your application is not running anymore, you go back to where your last sequence number is. You resynchronize to your last sequence number. Activity management pretty much is used for exchanging messages, and exception handling is just used for reporting errors. There are many protocols that are used with this layer, but RPC, Remote Procedure Call, is the one that is frequently used. It's a service that allows programs from one server to use programs on another instead of sending and receiving messages to and from one another.
I'm Scott. I'm going to be talking about the presentation layer. It's the 6th layer in the OSI model, located beneath the application layer and above the session layer. It's responsible for displaying or presenting the data of the application layer to both hosts. This is important when remembering that the two hosts may not be running the same operating system, because different operating systems have different ways of saving text files, music files, and multimedia files. There are 3 main functions of this layer. The first one being translation. This is the process of converting data files into a compatible format that the application layer can interpret, as well as the remaining layers below it. And an important protocol that uses this is the Multipurpose Internet Mail Extensions, or MIME, and this is basically implemented with the SMTP protocol from the application layer, the protocol that's used for email. So MIME is basically a format that every email has to follow, so that these different end systems can communicate without different formats. Another function is compression. This is the process of reducing the size of the bits. And there are 2 ways of doing this. You can either delete redundant information in the code or remove unnecessary information in the code. Compression is important because when you're transmitting data across the network, sometimes it can get congested and it can take a while. So just making compressing the file helps to increase the throughput of the file. And finally, encryption, probably the most important function of this layer. Encryption is basically the process of scrambling the text that is transmitted over the network so that no one else can see it in a way that only the sender and receiver can view it. And one popular protocol that utilizes this is the secure sockets layer. This is basically a form of encryption that works on a lot of websites, such as the Penn State Angel website or different commerce websites like Amazon or your local online bank. It just scrambles the message, the plain text that you're sending across, so that no one else can kind of tap into your packets with Wireshark and see what you're sending.
Alright. When it comes to security in the OSI model, all the lower layers must be secure for the top layers to be secure. The presentation layer may transform a file when it's sending a file into code such as binary or Unicode. Unicode presents vulnerabilities. The vulnerability allowed attackers to hack into your web server and use Unicode directories that they would not normally be able to access. Windows recently released a patch to fix this problem. To secure the presentation layer, you can use an SSL, Internet Protocol Security, a virtual private network, or authentication. When it comes to the session layer, the biggest security concern is a TCP session hijacking. That's when a hacker takes over a TCP session between two machines. A man-in-the-middle attack would be an example of this. That would be when someone is in the middle and uses a sniffing program to watch the conversation. It's also important to secure the session layer. 4 ways to secure the layer is an SSL, a secure shell, Kerberos, IPsec, and authentication.
Alright, so as we kind of covered, just to recap, the session layer aids the transport layer, the presentation layer aids the application layer, and there are vulnerabilities, and the best way to kind of combat that, the common theme was kind of that authentication and SSL. So does anyone have any questions?
The last one.